Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Triangulation is brought to you by Cashfly at CACHEFLY.com. This is Triangulation, episode 222, recorded Monday, October 26th, 2015. Steve Jurczyk from NASA. Triangulation is brought to you by Boll & Branch, the most comfortable sheets on the planet. If you order right now, they'll give you $50 off a set of sheets plus free shipping. Go to BOLL and branch.com and use the offer code Triangulation. And by Blue Apron. Blue Apron will send you all the ingredients to cook fresh, delicious meals with simple step-by-step instructions right to your door. See what's on the menu this week and get your first 2 meals free by going to blueapron.com/twit. That's blueapron.com/twit. And by Epson's new EcoTank printers. With Epson's line of Super Tank all-in-one printers, you could print thousands of documents without running out of ink. EcoTank is loaded and ready to print when you are. Visit epson.com/ecotank to find out more. It's time for Triangulation, the show where we get together with some of the most interesting people in technology, and we get to really sit down and talk. And I brought in reinforcements for this show. Our guest is Steven Jurczyk. He is Associate Administrator for Space Technology at NASA. Okay, that's cool. Right there, that's cool. And I'm thrilled to have him. Thank you for joining us today, Steven.
Oh, no, I appreciate the opportunity.
And joining me to interview Steven, longtime friend of Twit, host of Futures in Biotech. He is himself an entrepreneur in the genomics. His company is Aromics. Mark Pelletier, thanks for joining us today, Mark. In fact, thanks for arranging this interview for us.
It's always fun.
Yeah.
I mean, this is a great opportunity to speak to the people who change the world. So,
I feel like that. I feel like that. So tell me a little bit, Stephen, about your job. What is it that what you do as associate administrator of space technology? Sounds cool.
Well, essentially, I run the what's known as the cross-cutting technology programs for the agency. So we have 9 programs that do everything from very basic research to flight demonstration of technologies in space. And our goal is to enable human exploration of the solar system, those technologies, as well as the next generation of robotic missions to do the science that we do here at NASA, which is astrophysics, heliophysics, the study of the sun and the interaction between the sun and the Earth, planetary science, and Earth science.
It feels like lately NASA's mission has expanded, enlarged, and its role has increased. It feels like we're on an upswing. Is that an accurate perception?
You know, I think it is, primarily for several reasons. First, you know, the human spaceflight program has been, you know, kind of quote unquote stuck in low Earth orbit. We're doing some great research on the International Space Station, but humans haven't been beyond low Earth orbit since Apollo. And so we are putting plans in developing the technologies and putting plans in space to get back into what we call cislunar space, operating human spaceflight missions in the lunar neighborhood, and then eventually onto asteroids, moons of Mars, Mars orbit, and Mars surface. So that's a large and multi-decade, multinational endeavor. We're not going to do it alone. It's definitely going to be a collaboration of nations worldwide, just like the International Space Station was. And then we continue to expand our portfolio of robotic missions, both Earth-observing missions, which are really important for things like to really determine what's driving climate change, as well as the study of other planetary bodies and looking for planets around other stars and the origins, doing research on the origins of the universe. So, yep, I would say very busy, lots to do, and lots of missions to get done in the next coming decade or decades.
It's so exciting, you know. We with some big wins of late. New Horizons has been so exciting. Curiosity has brought us such interesting stuff, including the discovery of liquid water on Mars. But I think the heart of the human imagination is manned missions. And I understand, I think there's a really good cause to be made that we shouldn't be sending humans to Mars, and that we can learn as much with robots. But it sounds like manned missions are part of the plan, and I'm curious why.
Yeah, so there are several reasons why. You know, one is a human geologist can do more research in 15 minutes than a robot can do in days, weeks, and months right now. Now, as we advance, you know, autonomy, improve the reliability of systems, take advantage of artificial intelligence and virtual reality, we might get to the point where robots can rival what a human geologist or a human scientist can do on the surface of Mars. But right now, having that human interaction with the environment, we can do way more science in a much shorter period of time. The other thing is we have been and will continue to be a nation of explorers, you know, and we've led the way in space exploration for the entire space age. And so this is just a continuation of that, of exploring, continuing to explore and leading the way in space exploration. And the world still turns to the United States and NASA for leadership and exploration, both robotic and human exploration. And then I truly believe that we're meant to be a multi-planet species, that at least a two-planet species. And we are meant to not only go to other planets, but also in the longer term colonize other planets and kind of not only first Mars and then maybe beyond as we advance the technology and our capabilities. You know, and Mars is the most Earth-like planet that's our nearest neighbor in the solar system, and there's lots to be learned and lots we can do on the surface of the planet. Yeah, there's many reasons for human exploration of the solar system, starting with Mars.
Can't tell you what a big smile comes across my face when you say we are meant to be a two-planet species, right, Mark? I mean, that's what you want to hear.
Before we start talking about terraforming Mars or even Venus.
We don't have to terraform it. It's got water.
Yeah. Right. Well, there's still a little terraforming that needs to be done, you know, at least indoors. We can do indoor colonies.
Grow potatoes,
you know. We try to figure out, why do we do this? Why do we go to the moon? Why do we go beyond? Clearly, there's a certain element of, well, it really doesn't need to be done because humans can live on Earth, and we need to fix Earth. But can one say that there's an argument to be had of pushing those frontiers forward allows us to translate all the technologies that we learn about putting a human on Mars? Those technologies can benefit mankind on Earth. Is that also a part of the argument beyond just inspiring us to?
That is. There's actually two parts of the argument for benefit back to Earth. One is scientific. As we learn more about the evolution, obviously at one point we're finding out Mars was a very wet place and most likely a warmer place. And by further studying the evolution of Mars as a planet, we can also learn about how hundreds and thousands of years from now, and even millions of years from now, how the Earth is going to evolve. So that's that kind of comparative planetary science that we get by studying other planets, and Mars is the closest one to Earth, and so we get that. But also the technologies, and just like we did it without the space program driving integrated circuits, we probably wouldn't have at least the speed of innovation in microchips that we did in the 60s. There are technologies, many technologies in things like energy generation and energy storage, and as well as things like technologies we're going to develop to sort of live off the land. We call it in-situ resource utilization technologies, where we're going to use local resources to generate everything from building materials to grow food to generate oxygen and fuel from the Martian environment. So those definitely will translate back into benefits to Earth from a technological standpoint. So I think both scientifically and technologically, it's really, we will get benefits back to Earth.
Do you have a licensing program where people can license technologies developed at NASA to commercialize it on Earth?
We do. It's actually run out of a different office, the chief technologist's office. But we have a program where inventors can submit their inventions for patents, and we actually work with inventors within the agency to patent their technologies. And then we have a commercialization program that licenses those technologies out to industry. I know, well, back at my old organization, the Langley Research Center, we had our most prolific organization for invention was the Materials Research Group. They invented, back in the day, polymer composite materials and fiber reinforced-based composite materials, and now nano-based materials. And we tend to patent those and license those to industry. And the nice thing about that is the inventors get a portion of the licensing or royalty fees, and then the organization gets a portion of the fees to invest back in research. So it's a kind of a win-win for both the inventors and the organization.
What is the role of private space programs? And do you feel like there's a logical demarcation between what governmental space programs can do and privately owned space programs can do?
Well, there's a certain demarcation of, essentially we're looking to turn over operations in low Earth orbit to commercial space enterprise. And so that's where we're focusing our investments with the commercial space enterprise. And then as NASA, we're investing in the technology and the capabilities to explore beyond low Earth orbit when it comes to human exploration. However, for example, we are also funding and buying, quote unquote, commercial services, both SpaceX, space exploration technologies, and orbital sciences. We contract with them to deliver cargo to the International Space Station. And that's not paying for the development of a system that NASA is going to operate, but pay them for services to deliver a certain number of tons of cargo to the space station. We're also in the development stages of what we call the Commercial Crew Program. That SpaceX and Boeing are going to provide commercial transport services to and from the International Space Station. Again, it's a different model. We're not buying and operating a system. We're paying for services. Now we're going to ensure that their system is safe enough to put our crew on there through I call kind of a modified certification approach. But yeah, we're really kind of looking to turn low Earth orbit operations over to commercial through buying services versus buying systems.
And that, of course, develops their skill set, makes them more useful in other ways down the road.
Exactly.
Yeah.
And we hope to stimulate. So the key is, one of the keys is to get the cost per pound of payload to orbit down. So the cost of getting a pound, you need a lot of energy to escape the gravity well. It just takes a lot of energy. And so we're essentially relying on kind of 1950s ICBM rocket technology. Yeah, right. Chemical propulsion, right?
Yeah.
The oxidizer and the fuel might be different, but it's a chemical reaction, right, and a controlled explosion, right? So to generate that energy to escape the gravity well, and it costs about $10,000 per pound.
Wow.
To get to low Earth orbit.
Holy cow.
And so SpaceX is beginning to change that equation by lowering that, closer to maybe in the $1,000 to $5,000 a pound range. But if we can really get it down, to hundreds of dollars per pound versus thousands, then that'll open up commercial enterprises, things like manufacturing in space, pharmaceuticals and other biotech industry that could benefit from the zero gravity environment, and tourism. Bigelow Aerospace is doing development in inflatable habitats or orbiting structures that can act as hotels or laboratories, and even maybe mining asteroids and mining other bodies. So, but it really is the technology to do that, and then the lower cost access to space is really required to enable all that.
I think it's funny that you mentioned space tourism. I imagine that there is at least some segment of NASA and the trained professionals at NASA who wish tourists would not enter the space. Just stay out of there. This is dangerous up here. Is space tourism an important part of the mission, and why?
It's not an important part of the mission, but if we could enable something like space tourism, then that creates a market at a scale for low Earth orbit,
Oh.
where then we can drive the cost of services down for NASA as well as others, right?
Got
So you
it.
need kind of, so the only quote unquote killer app for space to date has been commercial communication satellites, right? And communication services from geostationary orbit. That's been the only really, commercially viable space enterprise. And so we're looking to expand the viability of other enterprises like, manufacturing, other research, tourism, mining, and resource prospecting, so we can expand the marketplace there and get those services at lower cost by trying to get some economies of scale.
We've had Chris Lewicki on the show, Planetary Resources. Of course, they want to do asteroid mining, and there would be another commercially viable, very viable, potentially, use of space.
Absolutely.
Yeah.
Yep. There are some precious metals and other resources on asteroids that you could, if you'd figure out how to extract them cost effectively, there could be a business case that closes there for something like asteroid mining.
Mark, I want to take a break because we got to do an ad, but I think we should talk about Mars, don't you, Mark?
Yeah, well,
I want to talk about Mars.
well, we haven't discussed the lunar neighborhood yet.
Oh, okay.
Yeah.
Lunar neighborhood, that sounds good too. Low Earth orbit and lunar neighborhood, and then Mars.
Europa.
It's just logical progression. We're going to talk more in just a bit. Our guest is thrilled to do it too. Stephen Jurczyk. He is the Associate Administrator for Space Technology at the National Aeronautics and Space Administration, NASA, which is the best title ever. And Mark Pelletier is joining us. From many years as the Futures in Biotech host. I had so much fun hosting that show with you. I learned so much. And he is doing his own genomics startup, and he's got new stuff coming too, which I'm going to find out about in a little bit. But first, let's talk about my sheets. You never know where sleep comfort is going to come from, and I have been sleeping on the nicest sheets ever from Boll and Branch. If you think about it, you spend some nice money on clothes to wear so you look good, but 8 hours a day, you're between the sheets. And those sheets should feel good. They should be comfortable. You don't want to skimp on your bedding. And I tell you, I've slept on some bad sheets before, but not my Boll and Branch sheets. Turns out thread count has nothing to do with quality. Boll and Branch sheets are different. First of all, you can only get them online, bollandbranch.com. That way, you're not paying for the store, the lights, the beautiful display. You're paying for the sheet. They're made entirely with organic cotton. They are certified fair trade, so you can feel good about these sheets. And I'm telling you, you will love it. 3 U.S. presidents sleep on Boll and Branch sheets. They've been around for a long time. It's actually a very well-known name in the field, and they make such nice sheets. And because they cut out the middleman and the big markup at department stores, did you know department store markups are up to 800%? 800%. Now you know why those sales are so good at department stores. Then it's only 400%. You're getting amazingly luxurious sheets. I'm talking a couple $100. See that box they come in? This would be such a great gift for a wedding gift, for a baby gift, a new couple. I was so pleased when my Boll and Branch sheets came in this beautiful ribboned box. I felt like, wow, this is something special. And they are so confident that you're going to love these Boll and Branch sheets. They'll let you try them completely risk-free for 30 nights. It even gets better if you order right now, $50 off a set of sheets plus free shipping. Boll and Branch, B-O-L-L, like cotton boll, right? bollandbranch.com. And you have to use the offer code Triangulation to get that $50 off. BOLLANBRANCH, bollandbranch.com. Just use the offer code Triangulation for incredible linens at an incredible price. And you'll feel good about sleeping on them because they're fair trade too. Boll and Branch. We're talking to Stephen Jurczyk. He is Associate Administrator of Space Technology. Mark Pelletier is reinforcements on the show today. I'm so glad to have you. Mark, I've been hogging Stephen, so please ask away.
Okay, so you talked about, thank you, Leo. You talked about bringing the cost down of space flight, so that there could be a commercialization of lower Earth orbit and so forth. I'd like to ask you, what kind of rocket designs are really sort of gaining ground as to lowering that cost of getting out of, getting stuff up into space, and then outside the gravity well?
Yeah. So the the first thing is more of an evolution of the current design, and that is reusability. You know, a tremendous amount of the cost of a rocket are the engines, manufacturing the engines, and it's also a big, besides the fuel, it's the biggest mass. And so you have SpaceX trying to land their first stage back on a platform in the ocean.
Not always successfully, but yeah.
Yeah, well, no, they got a little bit closer last time.
One thing I learned.
You can see the reaction control engines on the top of the rocket fighting to keep it upright. They just couldn't do it. One
thing I've learned from watching movies, in The Martian especially, is space is hard.
It is tough. It is tough. There's no doubt about it. And also, United Launch Alliance, their Vulcan rocket is looking at actually separating the engines as a module and using an inflatable entry vehicle to bring them back into Earth, and then do a mid-air recovery of the engines with a helicopter so that they can bring them back and have very little refurbishment. So that's evolutionary, right? Reuse can lower the cost. And ultimately, we like a cost-effective, fully reusable spacecraft or rocket. And so we've been working on things like hypersonic air-breathing propulsion. And what that allows you to do is you can use oxygen, atmospheric oxygen, as the oxidizer. You don't have to bring the liquid oxygen with you. So that reduces the weight of the vehicle and allows more. And if you have a lifting body or a winged vehicle, allows more close to aircraft operations, and also allows reusability. So we did back in the 2000s, early to mid 2000s, we did a Mach 7 and Mach 10 flights. It was called HyperX or X-43A, of a hypersonic air-breathing engine. Very small-scale vehicle, but we demonstrated even at Mach 10 that you can get positive thrust out of a system that was what we call a airframe integrated scramjet or supersonic ramjet. We've collaborated with the Air Force to advance that technology, and we're going to continue to do that. So to hopefully in the coming decades develop a fully reusable, operationally efficient launch capability.
Are space elevators just pure sci-fi?
No, they're not. Actually, they are physically possible with the right technology. So I would not rule space elevators out of the realm of possibility.
The idea being you get out of the gravity well in an elevator, and then it's a lot cheaper because now you're out beyond the...
Exactly. Yeah. The higher altitude you can get, the easier it's going to be able to achieve escape velocity and get beyond Earth.
You cautiously call them you don't use the word spaceship. You always use space vehicle or spacecraft, but it's kind of fun that you can talk in a language that includes spacecraft as a field of work. It's just brilliant. I'm always in awe. Maybe you could tell us a little bit about the Vulcan rocket, and where it's going. And
with ULA, yeah. I mean, they're essentially, well, we have a challenge, right, that we use Russian engines on our current rockets, the RD-180. And so given the recent, geopolitical challenges, particularly with Russia over Ukraine, one of the motivations to moving off of the Atlas and the Delta is to have a rocket with a U.S. developed engine. And so that's the first goal for ULA, is to develop a new first stage with a U.S. made engine. And then they'll also develop the next generation upper stage. And that'll provide a reliable launch capability at lower cost, replacing the Atlas and the Delta. But we're really working with them on is the approaches for recovering the first stages. We developed the inflatable entry vehicle technology to land larger masses on the planet of Mars. So the idea is the system packages up very nice in a very small volume in the shroud of the launch vehicle, but deploys to a very large surface area, so you can get the drag to slow you down when you're entering Mars, as well as to take the air heating as you're traveling at upwards of 25 times the speed of sound when you hit the top of the atmosphere at Mars. And so we're we're adapting that technology for Earth entry for the engine recovery, and we're also working with them on the mid-air recovery operations to actually, have the parafoil fly the engines back to the helicopter for, very efficient recovery. So yeah, that's what our main collaboration with them.
You say it very. It's like it almost flies through here. It's difficult to grasp. Mid-air recovery. Maybe you could explain a little bit about.
Yeah, so we've done this.
Sounds like the helicopter's catching the thing as it comes in.
You see, exactly. So back in the day, the spy satellites used to drop, film canisters, right? Used to drop film canisters overboard, and we do mid-air recovery of film canisters, right? Keyhole. So we've been doing mid-air recovery for a while. However, this would be a much more massive system to recover.
Do you build a giant mitt? What do you? How do you?
Yeah, so it's actually a device on the parafoil that the helicopter grabs, and it slowly transfers the load from the parafoil to the helicopter, so we don't kind of upset the dynamics of the helicopter. And we've actually demonstrated that transfer of of a large mass from a parafoil to a helicopter with test masses that were thousands of pounds. So the technology is not that crazy. Yeah.
So you have this huge engine coming down. You has a parafoil to slow down its descent, and the helicopter comes and descends upon it, not letting it touch the ground.
Correct.
Wow.
Correct. So
Why would
it intercepts. You actually fly.
Why?
Parafoil's got it, so we can control the trajectory of the parafoil actively, and so we can actually have the helicopter stay in one spot, generally fly the parafoil back to the helicopter, and then have it rendezvous with it, and through this mechanism, kind of grab the engines on a bridle and pick it up off the chute and gently lower it down to the ground.
So clever.
Was this inspired by Batman, or
So
whose
clever.
idea was this? Where did they get the idea? Because it's brilliant. But why do you want to not just let the I guess is it because it's a big machine you don't want falling on a house?
Exactly.
We can guide the parafoil.
Mostly you want to not have any damage to the engines. Okay, so if you land them, you have to land them. You have to land them very, very softly to have get the pristine engines back like you can with a mid-air recovery. So the mid-air recovery allows you to get the engines back pretty much in the condition that they were when they cut off, and then that makes the business case close. Because if you have to do any sort of refurbishment on them, given the cost of the operations to recover them, if you have to do any refurbishment on them, then the cost of recovery and refurbishment is more than building new engines. So you just go build new engines. So that's the idea: is you want to get the engines back in the most pristine condition as possible, so you can get the business case to close on recovery.
You have some good pilots as well.
Yeah, they're guys who the Sky Crane. They're guys who know how to do this.
Unbelievable.
I want to go to Mars.
Okay.
So where?
do I.
Yeah. We all do.
No, I'm okay.
You don't want to go to Mars? All right. I've for a long time in talks and speeches I gave, and this is more an inspirational thing to say than I don't even know how true it is. I said that right now there's a kid in high school who will be the first person on Mars. Are we in that time frame, or is it more distant than that?
Oh, let's see. We're talking about people on Mars in the 2030s.
Oh, so it's not that distant.
It's not out of the realm of possibility.
I used to say it a long time ago.
Yeah.
Then it wasn't so good, but now you could say it.
Now you could say it. I think around, you could argue, whether it's the mid-2030s or late 2030s,
Wow,
and we got a lot of work to do to get there, but, that's what we're shooting for. Yeah.
That's amazing. And so I'm of an age, I grew up with the Kennedy space program with Mercury and Gemini and Apollo, and how inspiring the 60s were. And we got to see it launch after launch. And there was very much this sense of building towards a goal, because President Kennedy has said before this decade is out, we will land a man on the moon. It's not quite so obvious the progress we're making towards Mars. I mean, we've got Curiosity, we've got some amazing pictures. We're learning much more about the red planet. But what are the stages there? What is the Project Mercury, for instance?
Yeah, so we don't quite have a Project Mercury yet. We're still developing the architectures, the systems concepts, and more importantly, the technologies enable those systems to come up with what the Project Mercury would look like. And where we're at now is we're iterating between, architectures, systems, and technologies to try to figure out what's the most affordable and safe way to do human missions to Mars. So right now we're doing research on the International Space Station, particularly on research to keep the astronauts healthy, safe, and productive in the space environment, and both through protections and countermeasures. So that's really important. And we're also developing, robotics technologies and demonstrating technologies on the International Space Station. Next, we'll use the Orion spacecraft and the Space Launch System, the SLS rocket, to launch astronauts to what we call cislunar space. Right now, either lunar orbit and or lunar surface. That would be through an international collaboration, and learn to operate, learn to do sustained operations beyond low Earth orbit. And so right now we're putting plans in place over the next couple of years to develop what we call a habitat, but it really would be a space station or space outpost in lunar orbit. And to demonstrate things like, environmental control, more, highly reliable, highly efficient environmental control and life support systems, the autonomous operations that we need to operate over, many months, if not years. We're going to look at what resources we can use on the moon. If we use the moon as a base or a staging point for missions to asteroids and onto Mars, we believe there's water on the moon at the poles. And so the question is, how difficult would it be to extract that water and turn it into fuel? So we could essentially have a rocket fuel depot on the moon. And so that would be the next step is operations in deep space, but within days of being able to return to Earth. Right now on station, we return in hours. If we're at the moon, we're going to be able to return in days. And then beyond that, we're talking about, not being able to return for weeks or months. That's a whole nother leap in, keeping the crew safe and dealing with medical emergencies and all that. So that would be the follow-on missions. We do have a mission that it is in the planning stages, called the Asteroid redirect mission. It has two phases. One is a robotic mission that would go to an asteroid and rendezvous with an asteroid and actually scoop up a boulder from that asteroid and then bring it back to a stable lunar orbit. And then the crew would launch crew to it. It would kind of rendezvous with it, do a little rock climbing, sample collection, and bring those samples back. So that's one way in which we can demonstrate in kind of a stepwise approach, demonstrate going and getting an asteroid or a piece of an asteroid, bringing it back and having crew interact with it. And then we'll get samples back and look what's there. Go ahead.
How big would the rock be that you'd be going to recover?
The rock would be in the 5 meter to 10 meter range, or probably 5 to 8 meter range. Wow, we're talking about it's a big rock because we're talking about rendezvous with an asteroid that's 300 meters across. And also we would also demonstrate planetary protection. So after we grab the boulder off the surface, we would then have the spacecraft orbit the large asteroid, and demonstrate we could deflect the trajectory of the asteroid just by using the gravitational forces between the spacecraft and the rock, piece of the asteroid, and the asteroid. So it's called the gravity tractor approach to planetary protection. So that is, if we can detect asteroids that may hit the Earth far enough away, we can intercept them far enough out, and then it wouldn't take much of a deflection to have them miss Earth, and then we can use just the gravitational forces and this gravity tractor approach to protect the planet.
Has anybody done the back of the envelope calculations to the size of the ship, the mass of the ship, to be able to deflect that few fractions of a degree enough to miss Earth?
Yeah, it actually, I'm trying to remember, oh gosh, we're talking thousands of pounds, not tens of thousands or hundreds of thousands of pounds. Yeah, it just takes time, right? The lighter the ship, and this is the enhanced gravity tractor approach, because we're gaining additional mass from the rock off the surface. And so that could be an approach where you actually augment your launch mass by grabbing a rock off the surface. So yes.
So something the size of a space shuttle could do it.
If given enough time, yes.
How is that really? It's the Bruce Willis mission. Is it really?
Yeah, well, the fact they'll destroy asteroids.
Yeah, we don't have to destroy it. We can just push it, nudge it, even.
Just nudge
tractor
it.
beam
Again,
it.
Nudge it.
Yeah, tractor beam it. And the key is being able to detect it far enough out, because if you can do that, it doesn't take much of a deflection to have it miss the Earth. Now, if it's a little bit closer, then you might not have enough time, and you might have to go for the Bruce Willis.
How urgent is that, by the way? Is it really I mean, it's been a while since an asteroid's hit the Earth.
Yeah, so we call it one of these 1-5 events, where 1 means the probability is really low, and 5 means the consequences are really high or really bad.
Yeah.
and so to ignore it, so it's a very low probability event.
Right.
Based on the current knowledge of the distribution of asteroids in the solar system. However, if that low probability were to happen, it would be bad to not have a plan.
Bad news. Yeah.
Is it 1% chance every 1,000 years? Something of that order of magnitude?
I think it's even lower probability than that. Okay. I can't remember off the top of my head.
But if
I thought I read a Nature paper a while back.
If NASA doesn't...
Okay, so I have to qualify that. A asteroid large enough to do significant damage.
We've had asteroids hit recently. We
have planetary bodies enter all the time.
All the time.
They're usually small. Their composition and their size is small enough that they break up in the atmosphere.
Right.
We actually, obviously, a few years ago had the one in Russia that was larger. That didn't completely break up. It broke up in the atmosphere, but it broke up at a fairly low altitude and created some damage. And so, there are asteroids. There are planetary bodies that enter all the time, right? But we're talking about one that's large enough to really do some damage. Dinosaur
tractor beam,
dinosaur extinction, size.
That size. Yeah.
What about solar sails? I mean, if gravitational pull from 1,000 to 2,000 pound craft is strong enough, how about putting on a square kilometer of solar sail?
Yeah, I think if you made I'd have to have the people who do the work run the numbers. But yeah, again, it's a matter of how large a solar sail can you build? So how much force can you get from a solar sail? And then, how much time do you have? How much time do you have to, have a craft latch on to the asteroid with the solar sail and have that force deflect the trajectory of the asteroid?
We're talking to Stephen. Let's take a break, Mark. Hold that question if you will. We're talking to Stephen Jurczyk. He is the Associate Administrator of Space Technology at NASA. And we love NASA. Everybody loves NASA. We watch NASA TV. We talk about the amazing missions, especially of late, like Kepler and New Horizons. I mean, it's just been really exciting. And there's more to come. And it's not science fiction. It's science fact. And that's what I really like about it. We'll have more in just a second. But first, a word from Blue Apron. I love this idea. Blue Apron wants to encourage you to cook. And, sometimes I feel like I don't want to eat out. I don't want to have fast food. I don't even want to go to a nice restaurant. I want to cook at home. The problem is you've been working all day. You're tired. It's such a nice thing. I got to tell you from my own experience, when you get home and there's the Blue Apron box, and inside is going to be, there's a delicious meal. Actually, there's usually comes with 3 meals inside. A delicious meal that you'll have ready in half an hour. You'll cook something wonderful and unique. They have plans for 2. They have plans for families. The plans for families have kid-friendly ingredients. About a little less than $10 a meal, but more than that, it's home-cooked, fresh ingredients, never frozen. The produce is always from local farms and picked at the peak of freshness. It's seasonal, and you're going to have an amazing meal. It comes with the recipe cards, everything you need. There's even videos on the site to show you techniques if you need to know how to mince a scallion or peel an onion. It's all there. And you're going to become a great cook. You're going to have these recipes under your belt. You're going to add them to your repertoire. I love Blue Apron. And no matter what your dietary preference, they make it a breeze to discover and prepare dishes like Jamaican jerk chicken and maduros with stewed collard greens. See, I always wanted to make collard greens, but I never had the confidence or how to pick them or anything. But this gets you there, and then acorn squash tempura tacos with smoked paprika lime sauce. Ingredients you may not have used before, but will now that you know how to use them, will love them, like watermelon, radishes, and farro, purple potatoes. We found I had an Asian recipe I just loved. It was called 3-cup chicken. It was a Taiwanese recipe, and it used they had a bok choy variant that I'd never tried before, and now it's just like, I love it. It's so amazing. It's delicious. It's good for you. You'll learn new recipes. You'll have fun. If you get the family plan, your kids will have fun with you. I want you to go to blueapron.com and find out just for yourself by getting their first 2 meals free. This is what's on the menu this week. By the way, never a repeat. Pork meatballs and butter lettuce cups. Oh, look at that. That looks fabulous. By the way, the dipping sauces that they do, incredible. Incredible. Jamaican jerk chicken and maduros. Salmon pastrami on rye. Baked Sicilian-style rigatoni. Oh, you know, it's hard to do these ads. They make me hungry. BlueApron.com/twit. Get your first 2 meals free right now. BlueApron.com/twit. And your honey, your children, your friends will suddenly say, boy, you got to be a really good cook. What happened there? You can just go, I don't know. Blue Apron. We're talking to Stephen Jurczyk. He is the Associate Administrator of Space Technology at NASA. We're talking about Mars. We're talking about missions to move asteroids. How many?
I've got a
Go ahead.
question.
Go ahead, Mark. You start.
Before we should get to Mars, and I'd like to know what the spaceship designs look like. Are we going to do the shuttle back and forth between maybe the moon and Mars to sort of get us there using rocket fuel made on the moon? But before we get there, we're talking about saving the world from a near-Earth asteroid or collision or big giant rock. How about blowing the thing up? Is that ever even been considered? I mean, of course it's been considered, but is it possible?
Yeah, it's been considered and it's possible. It definitely is. Yep.
Okay.
And
Check.
Yeah. So, and that would be that. You know, if it was closer than we had, you know, if we didn't have the time to deflect it, then that would be an option. The thing you got to worry about is you're creating a large debris field.
Yeah, a lot more rocks.
Yeah, you just need to make sure that those rocks are small enough that they're not going to cause a problem. But yeah, it does create a larger number of small rocks, and hopefully, if they're small enough, you've actually done the job.
Right.
Is there someone somewhere in a drawer, maybe one of your drawers, a roadmap to Mars, or is it not quite coalesced? I mean, I have to say, I think going to Mars has got to be several orders of magnitude more difficult than going to the moon. It's much more distant. There's all these problems you have to solve getting back. You know, Kennedy didn't just say put a man on the moon and get him back safely. That's another question mark. Some people have even proposed missions to Mars that are one-way missions. There's got to be a lot of question marks open. But is there a roadmap?
You know, we have a roadmap of technologies and capabilities that we know we're going to need.
Problems that have to be solved.
Problems that need to be solved. So,
Yeah.
so for example, Curiosity rover was 950 kilograms, or 1 metric ton, the largest thing we've ever landed, or anybody's ever landed on the surface of Mars. And we use the same entry vehicle, you know, design and shape, 70-degree sphere cone, that we use for Viking and all the other missions to Mars. We use the supersonic parachute. It's called disc gap band supersonic parachute. Viking, we used it on Viking. We used it on Pathfinder, Spirit, Opportunity, Phoenix, and Curiosity. Now we've innovated the landing part, right? First the airbags on Pathfinder and Mir, and then the propulsive descent on Viking and Phoenix, crane. and then the sky crane for Curiosity, which was pretty cool, right? Because we couldn't use the airbags because the system was too massive. But we've kind of come to the end of the line on what we can do with the Viking technology. About 1 metric ton is what we can do with that EDL architecture. So we need to come up with a new architecture and new technologies to enable that architecture to land like 20 metric tons or so, 20 times what we could do before. And that's for the MAV. You know, in the Martian, they had the MAV, the Mars Ascent Vehicle.
That's to get off Mars,
And exactly, to get off Mars. And we plan a round trip. We're not doing the one-way trip. So you need the largest piece right now that you need to land is that Mars Ascent Vehicle. And it's on the order of 20 metric tons. And so we need to figure out how to, and so some of the tech to land that much mass. And so the thing about Mars, we're the only nation that's been able to successfully land something on the planet that actually functioned after it landed. And so landing something on Mars is hard. It has a poor excuse of an atmosphere. Its pressure is about equivalent to 100,000 feet on Earth, but it has enough atmosphere, and the atmosphere is dynamic enough that you need to worry about things like aerodynamics and aeroheating and changes in density profiles due to dust storms and things like that, weather, right? So it's tough. And so we're developing things like I mentioned, inflatable entry vehicles that can inflate to, 15 meters across, 20 meters across, maybe even larger, to get a large drag area to slow down from hypersonic speeds to supersonic speeds. Looking at things like supersonic retropropulsion, firing rockets at supersonic speeds to slow down to subsonic speeds so we can get on a subsonic chute. And then we're looking at, do we use something like, and we're going to have to use propulsive landing too to land something that big. So there's a lot to do there. And we know, regardless of what, our other pieces of the architecture look like and the systems look like and other things, we're going to have to land things that are way more massive than we can land now. So that's an example of, technology that we're working on and problems that we're solving. Crew health and I'm sorry, go ahead.
Sorry, did you say supersonic retropropulsion?
Correct. So
is that a heat shield problem? Because when you're coming down on Mars, you still have that atmosphere. You have to have a heat shield, but isn't that become a big encumbrance to getting back off the planet?
Oh yeah, I mean that the thing about entry, descent, and landing on Mars too is you have to you reconfigure the system about 20 times on the way down, right? First you enter, and then Curiosity actually was guided, so it flew downrange. Then you have to it ejected masses, so we flew at an angle of attack, so we offset the CG on the vehicle, so we could fly at an angle of attack and get some lift. Then we ejected a bunch of tungsten slugs or masses to center up the CG again, right? And then we pop a cover off, and then we pop a chute out, right? And then we remove a heat shield, and then we remove the rover from the back shell, and then we lower the so it takes got to reconfigure the vehicle about 20 times, tens of pyrotechnic device firings to do that reconfiguration.
Holy cow.
And so that is kind of part of entry, descent, and landing. Is you have to reconfigure your entry system multiple times to get from hypersonic to supersonic, subsonic, and then actually land. And we're going to have to do that regardless of what the architecture looks like.
Is it propulsive landing out of the question, or?
No, it is. It's definitely going to be most likely way we get to, because I don't think we can lower 20 metric tons on a sky crane. Yeah, and I don't think we can land them with airbags.
Can't bounce people around like a rubber ball,
or even the equipment. So the equipment that large. So yeah, we're going to have to propulsively descend too.
It's very difficult. Gosh, you got to take all that.
It's going to be very challenging, and we're going to need a very high efficiency, propulsion system. No doubt about it.
It sounds like an underestimate for 20. I mean, 20 tons doesn't seem that much for a rocket that's going to get you off a planet. I mean, getting off the moon with super low gravity is one thing, but getting off Mars, the gravity is at a third of Earth, or is it like 0.4?
Yeah, I think it's 0.4, I believe. Yeah, 0.4 or 0.6. I'm trying to remember, but 0.4 sounds right. So we would land an unfueled rocket, right? So the MAV, so if you're familiar with the Martian, they landed the MAV and then had a plant to produce the fuel.
Yeah.
On the surface, right?
They landed years ahead, and then
years ahead.
Yeah.
We would actually. That's not very far off of what we would do. We would land a plant, a MAV, and a fuel production plant years ahead of time. Produce that fuel and make sure that we had enough fuel to fuel up the MAV, and then send crew and all that after all that was done. So yeah, we would. If it was a fully fueled rocket. I mean, a Mars descent vehicle would be way more than 20 metric tons.
Amazing.
I'd recommend two. Put two side by side.
Yeah,
I think we'll pitch in.
Little redundancy. That's part of the challenge with this in-situ resource utilization is, how do you these systems are going to have to operate on the surface, unattended for years most likely, and they're going to have to be highly autonomous and highly reliable. So how do you do that? How much reliability do you build in? Do you make them so they can be maintained robotically. So you have robotics, robots on the surface that can go up to them and change out batteries, change out other replaceable units. How do you actually have those systems produce the things, the fuel, the other resources that you need prior to crew actually ever getting there?
Talking to Steve Jurczyk about all the challenges there are so many, and NASA has so many things it would like to do, and I'm sure you would like an unlimited budget to do that. But one of the big challenges, of course, is getting the money to do it. There's another big challenge you kind of referred to, the international cooperation needed. And with a shifting international global situation, you can't get the rockets from Russia anymore. There's a lot of moving parts to this. What is your biggest challenge? What do you find the most difficult right now?
I would say the biggest challenge. So the biggest challenge for us is we're planning, not only multi-year programs, but a multi-decadal endeavor, and to kind of plan, the way the federal budget process works, you kind of plan on a yearly basis. And then you may not know what your appropriations or your budget is till months into the year that you're already in. So our planning horizon is not very compatible with the way the federal government plans and budgets. And that is a real challenge. The uncertainty really causes us to heartburn with trying to optimize what we can completely optimize what we can deliver for the money that we're given, right? And so that's kind of a really big challenge.
You're operating on a completely different time scale.
We are. Most agencies have programs that are year to year, or they can adjust very easily. Also, other agencies don't have the laws of physics to deal with.
Which is a shame. I think the rigor of the laws of physics could be welcome in some cases.
They deal with poles.
You plan a program and you can adjust it, but I think sometimes our stakeholders want us to do things that violate the laws of physics to make things work, and we just obviously that does not work.
Well, and also I know the GAO is always assessing whether the dollars spent are returning the appropriate dollars. But how do you assess the money spent on NASA? I mean, this is if there's a return, it's decades from now.
Right. NASA's an investment in the future. It's an investment in the future of exploration, the future of technology. You can argue the future of humankind.
I agree.
In the long term. So, how do you put a value on that? It's very difficult. And it's challenging to answer the question. Is we have poverty. We have
There's problems here at home.
We have environmental challenges here. We have problems here. Why are we spending money to send people to Mars? We talked about that earlier, but that it is very challenging, and we appreciate the the fiscal challenges in the country. I mean, we don't.
Of course.
We appreciate that there's not limited resources, and we pride ourselves on getting the most value for every dollar that we get, and we appreciate the challenges. But it's in an uncertain, just like in the business world, in our world too. Uncertainty is drives challenges and makes things more difficult.
I remember we talked to one of the mission directors for New Horizons, and now you're heading out to the Kuiper Belt. Now you have to decide which of the many projects you could attempt, and you have to go through a budgetary process and a scientific process. The complexity of what you do boggles the mind, and yet you do it with aplomb and with accuracy and an amazing safety record. I just feel like NASA is the best of us, and we're just so grateful that people like you, Steve, are willing to do this. And I know there's a lot of people who would like to donate to NASA. Is there any thought to crowdfunding or going to the people and saying, because I would love to give you money to do,
So one thing we have done, it's not quite crowdfunding, but it's kind of like, crowd intellectual property. And that is, in crowdsourcing, and that is we've done challenges and prize competitions. So one we recently kicked off is the 3D printed habitat challenge.
Oh, neat.
And we had 162 organizations and individuals respond to that. And the challenge is to use Martian soil, what we call regolith, a limited amount of water and a limited amount of power, to basically build the components using 3D printing technology, build the components of a habitat that then you can put together. And so 90 of those 162 we've deemed as qualified. We selected 30 to move on to the next phase. This first phase was the design phase. And 5 actually got awarded prize money.
Nice.
So they're going to now demonstrate a machine that's somewhat portable, uses a certain amount of water, a certain amount of power, to use, basically, well, we use regolith and trash, plastics and other trash, to print pieces of a habitat, and that we can maybe someday put together on Mars that astronauts can live in. So we've had challenges for the next generation, gloves for spacesuits, for rovers to look for samples on Mars and grab them and bring them back to cache them. Mars Ascent Vehicle challenges for a robotic sample return mission. And we've had everybody from individual inventors out of their garages to universities to larger companies participate in those challenges and win some prize money. So yeah, that's one way in which we're trying to engage.
That's a great idea.
What I call non-traditional, entrepreneurial, and really innovative organizations and individuals in what we do.
Donate brain power, not dollars. That's great.
I still posit that the intellectual property through the inventions that are coming out of the research at NASA have enormous value to society. If you look at what even what the various missions have brought to our day-to-day lives.
It ain't just Velcro and Tang, my friends.
No, and so, whole industries have been created from offshoots of NASA's work. So there is an incredible societal benefit and potential for direct, capitalization on a lot of projects that could be done. So it's time for every entrepreneur out there to mine through the NASA inventions and their patent applications and see what they'd like to do and how they'd like to commercialize some of this stuff and bring it to a widespread business model.
Mark, get your final questions ready. We're going to wrap up our conversation with Stephen.
Yeah, I think we got time for last question or so.
Last question, because I know you got things to do. You got a planet to explore. I guess I kind of asked the question already. What can we do to help? You know that we geeks love what you're doing. You've got fans, and we just want to help. So anything we can do, and certainly anything we can do to help publicize the efforts that NASA's making, we put ourselves at your service, Stephen. Keep up the good work, I guess. Mark, do you have any final thoughts?
Europa, are we going? Is there a 2060?
Yeah, we're going. We've got a mission we got an orbiter mission in formulation right now.
Neat.
And we're actually exploring if we can do a small lander and actually land on Europa and do some surface measurements. It'd probably be a very short mission, like a 7-day or so mission. But we're definitely designing an orbiter. It's tough for lots of reasons. Power. It's a cold environment, and power generation is really tough because you got the 1/r² law, and so solar power out there is really tough. And then the radiation environment, because of the magnetic field, large magnetic field of Jupiter, you got this very large trapped radiation environment. And so electronics are going to die our current electronics will die within 30 days or so in that environment. If you stay in that environment for
Could you map the sea?
So the huge challenges. I'm sorry.
Sorry. Could you map the sea below the ice by gravitational draw on the orbiters?
Exactly. So we will do gravity science to kind of map the movement of the ice sheets and hopefully, obviously the movement of the liquid oceans underneath. So we will absolutely either through Doppler radar or precise timing and navigation. We're developing a deep space atomic clock for improved deep space navigation. That with that precise timing, you could also map the gravity field and then map the ice sheet movement. So that gravity science is part of that mission.
One thing NASA's done really well is public outreach, and NASA.gov, a great site to visit. NASA TV, a great place. I like to just keep it on all the time. Stephen, thank you so much for spending some time with us. We really appreciate it.
Thank you for the opportunity. Really appreciate it.
Stephen Jurczyk, NASA Associate Administrator for Space Technology. We've got some final words with you, Mark Pelletier, in just a second. But first, a word about, speaking of an interesting technology, Epson printers and their amazing precision core technology. I think it's 40 million dots a second in their inkjet printers. These things are amazing, coming from an industrial technology now into your home, your small office, your business. And Epson's EcoTank printers, you pair precision core technology with EcoTank, and you have, bar none, the best printers made. EcoTank solves a big issue. This is a case of a company doing what's right for consumers. They're going to do it better with the EcoTank printers. They come in the box with 2 years of ink in those EcoTanks. And after 2 years, when it's time to refill, very economical bottles or bags to refill those printers. You take a look at the ET4550. There's a good example. It's a kind of a Soho printer. Comes with enough ink for 11,000 black pages or 8,500 color pages. That's about 50 ink cartridge sets worth. And then when you the replacements that come with low-cost replacement ink bottles, they're just knocking this out of the park. And the precision core technology means you're going to get super high speed. My precision core printer takes about a couple of seconds a page. It goes, and then there's a page. Vivid colors, laser quality black text. You get auto two-sided printing. I use that all the time to save paper. A 30-page auto document feeder, and it's wireless, works on your Wi-Fi, works with your tablets and your phones with Apple's AirPrint, Google's Cloud Print. I can even scan to the cloud. I mean, this is everything you want in a printer. An unbeatable combination of convenience and value. The EcoTank printers with ultra-low-cost ink replacements. You have the freedom to print without running out of ink. Take a look at the EcoTank printers today, Epson.com/EcoTank, and transform the way your home, office, or work group prints. Go scroll down a little bit, because the one I love to show, the big one, the big baby, the WFRD 4640. This thing comes with, get this, enough ink for 20,000 pages. This is for high volume business printing. You won't replace ink for 20,000 pages. Wow. That's like 40 reams of paper. And man, does it look good. 500 sheet capacity, 80 sheet rear tray, auto two-sided printing, copying, scanning, faxing. Epson.com/EcoTank. I love these Epson print. I really don't need the R4640, but I kind of want it. I just kind of want it. Epson.com/EcoTank. We thank them for their support of Triangulation. Well, this has been a lot of fun. Mark, you've been bringing us some great guests. I want to thank Mark Pelletier because I guess you kind of like space, right?
Well, anything science related, and I think it's an important time to put STEM ahead of some of the, or to help move it forward, because it's being pulled back and we need to move it forward. And today we talked about asteroid redirection, planetary protection, gravity wells, lunar neighborhood, hotels in space, and supersonic retro propulsion. If that's not a great conversation. I wish we had 6 hours, because every single one of these is a show. I know. It's really great stuff. Well, come back soon and bring us some more fascinating science, because I think it's so important. You know, we're a technology network. Technology is really science applied, right? It's the holding science in your hand, but it all starts with the basic science, the basic research, the insights, the hard work of science and engineering, and you know, we got to really celebrate that too, and get people excited about the field. Steve teleported us onto a spaceship. It's kind of like on Stargate Universe, where the kid just gets sucked up onto the spaceship, and then you realize, oh my God, here's our future. These interviews allow us that opportunity to really find out where that frontier is.
He said that 2030s we'd be going to Mars. I can't imagine. That's amazing. That's like
15 years.
15, 20 years from now.
15, yeah. On the earliest.
So I don't think I'm wrong when I say there is a kid in high school right now who will be the first person to walk on Mars. I don't think that's wrong.
Kid in college, actually.
Or college. Could be in grade school. You know, there's a little slop there.
Well, he's not going to be. You're not going to send somebody who's only 30 to Mars. You're going to need someone with
you know,
engineering experience and multiple space missions. So probably somebody in college, if it's the 15-year mark. So or even somebody who's
if we can change Stephen's mind about the one-way trip thing, could be you and me.
You know, I'll let you go, Leo. You be the
You'll find out more about Mark's company at aromics.com. Things are going well. Last time we talked, you were about ready to get approval, right?
Well, no, we're on schedule to be in the clinic within a year.
Clinical trials first.
With a drug that is prevents your brain from swelling from stroke, and brain swelling and stroke is the second largest cause of death globally.
Wow.
So if this works, then we're going to eliminate or greatly reduce the damage of stroke on Earth, and probably help 100,000 Americans a year survive, and millions around the world. Yeah,
pretty good for a Yale kid.
Well, the podcast on your network has helped me find out where the opportunities are, and get into the minds of we had Nobel laureates on a fairly regular basis.
Amazing people. Yep.
So you gave me a huge opportunity to really explore what needs to be done, and then pick a project and go for it. So
well, you grew my brain, and I'm still saying I'm willing to retire on Mars. I could see doing that.
It could happen.
It could happen. Thank you, Mark Pelletier.
Thank you.
Take care.
Have a great.
We do Triangulation every Monday, 11 a.m. Pacific, 2 p.m. Eastern Time, 1800 UTC, right here on twit.tv/live if you want to watch live, irc.twit.tv if you want to chat live. And it's great if you can to be here while we're doing it. But if you can't, of course, we make everything available. Everything that we do on demand, except for the chit-chat in between shows. We save that for live viewers. But if you want to watch the show itself, just go to twit.tv, and in this case, /TRI for Triangulation. YouTube.com/Triangulation. Of course, wherever you get your podcast. Subscribe. That way you won't miss an episode. We always have somebody interesting, some mind-expanding stuff on every Monday on Triangulation. Thanks for joining me. We'll see you next time. Bye-bye.